Hello, my dears. Today we'll be discussing the NCERT questions that are on page 159 of your textbook. We already discussed the questions that are there from the topic reflection by spherical mirrors, and we'll be covering the questions that are there from refraction by lenses in this session. The first question of of the questions: which of the following materials cannot be used to make a lens? See, any lens is a material which will be allowing the light to pass through, which means what? Refraction will take place. So water will allow the light to pass through, glass will allow, so is the plastic. Okay, so clay is the only opaque object here, so clay cannot be used to make a lens, as it will not allow light to pass through. Now the third question in your textbook: where should an object be placed in front of a convex lens to get a real image of the size of the object? We know in the case of a concave mirror or a convex lens, you will get the image size and object size to be same only when it is placed at C, or twice the focal length. In the case of a lens, it is in the convex lens, we will write your C as twice the focal length, right? So at the position 2F, you will have, when you keep the object, you will have the image size for image formed at the 2F prime, and it will be of the same size. And now the fourth question: a spherical mirror and a thin spherical lens has each of the focal length of minus 15 centimeter. The mirror and lens are likely to be both concave, convex. The mirror is concave and the lens is convex. Mirror is convex, but the lens is concave. Let me explain this. Concave mirror will give you a focus or on the left hand side from the pole. Likewise, the concave lens also will give you the focal length is on the left hand side from the pole. So in both these cases, the concave mirror and the concave lens will have the focal length as negative. Also remember, the power in the focal length is also a power of the concave lens is also negative. And now, see, if the question comes in the other way, a concave mirror and a concave, if a mirror and a spherical mirror and a spherical lens is giving the focal length of as positive, as both giving the positive, what kind of a lens it will be? It will be convex mirror and convex lens. Why? Here, if you see, the focal length will be from P to F. So it is on the image is found on the focal length is towards the right hand side from the pole or the geometrical center of the mirror. So F is going to be positive. Here also the focus is going to be from the optic center of the mirror of the lens to the right hand side. So here also F is going to be positive. So be it convex mirror or convex lens, focal length is going to be positive. Be it concave mirror or concave lens, focal length is going to be negative. So answer is both are concave. Both the mirror and the lens are concave. Okay. And now the sixth question: which of the following lens would you prefer to use while reading small letters found in a dictionary? See, in the dictionary you have small letters. You want to have an enlarged image. Okay. So which all lenses will give you enlarged image? Concave lens will definitely give you only diminished image. So which is the lens that you can use? You can use only convex lens. So now we are given two convex lens here. You have given a convex lens of 50 centimeter and also 5 centimeter. Now you have to apply the principle here. Which is the principle? A convex lens of a shorter wavelength will be bending the lighter through a larger angle. So they will be focusing them closer to the optic center, which means what? The focal length when F is going to be small, the power or the magnification given by the lens is greater. So you want a greater magnification, right? So you will be using a convex lens of focal length 5 centimeter because you want a greater magnification. And remember, when you keep the object At the point 2f, you will have the image formed at 2f prime of the same size. But whenever the object is placed from 2f to O, you will have your object size enlarged. But you will have your maximum enlargement of the image when the object is placed in between the focus and the optic center of the lens. So this is the position of your dictionary. And you will be holding the lens in such a way that if the focal length of the lens is 5 centimeter, means what? You will hold the lens, say like 3 centimeter or lesser than 5 centimeter from the dictionary, so that you will get the enlarged image of the words or the letters in the dictionary. And so your answer will be C. And now the ninth question. One half of a convex lens is covered with black paper. Will this lens produce a complete image of the object? Verify your answer experimentally. Explain your observation. And now you have to show experiment. So how do you write? It is your choice. If you have time in your hand, you can write your aim, requirement, all that. If not, you can go only with the procedure. You can say, take a lighted candle, fix the position of the object. So what here, the aim of the object is to find whether the convex lens is producing a complete image. For that, you need a convex lens. You want a black paper so that you can cover half of the convex lens. And you need a candle or a bulb as a light source or the image of the object. And now the procedure will be take a lighted candle, fix in front of the convex lens. Now fix the position of the object. You are not going to move the object, okay? Now you are going to adjust the position of the convex lens until a sharp image is obtained. Then mark the position of the lens there. And then you take out that lens, you cover it with the black paper halfway through, then place the convex lens exactly in the same marked position and mark your observations. So your observation is that you get a when the object is so you can write your observation as when the object is uncovered, you will get image and it is a real inverted and sharper image. And when half of the lens is covered, you will get a fainter but still a complete and real and inverted image. So how you have to you will have to verify your answer, explain your observation. So observation is that you will get a complete and fainter image, and the explanation will be, you can just simply draw the diagram. By this, the examiner will know that you know the concept very well. See, the light rays that pass, this much area is there for the convex lens, which is uncovered to produce an image. So all the light rays, you need to just draw three light rays. So one light ray that goes through the upper portion of the lens, one through the pole, and one through the lower portion of the lens. Then you you show this convergence and the image is formed here. Here, see, when the half of the lens is covered, the light ray that is that passes through the lens on the topper portion will be converged, but they will form a real image and a complete image. But see, the light ray will get cut from the light ray that goes and hits the pole will not be able to come through this way. It is get cut. It got cut. So anywhere from the lower portion, from the middle, will not be able. All the light rays are cut from here, and so they will not be converging. They will not be coming on the other side. So what happens? Only the light rays that are there on the topper portion will be converging to form the light ray. So form the image. So your image is a complete image, but yet a fainter image. So your inference is that the experiment proved that the convex lens will produce a complete yet fainter image of the candle even when half covered, because the light rays are being cut from the light ray that passes only through the top portion of the convex lens will be converged to make the image. So the image is a fainter one. I'm sorry, the rest of the answer is not coming in the screen. While the inference is that the light rays that are passing through the convex lens, uncovered portion of the convex lens will converge to make the image. So it is a painted image, but yet a complete and real and inverted image. Okay. And now the 10th question. An object 5 centimeter in length is held 25 centimeter away from a converging lens of focal length 10 centimeter. Draw a ray diagram and find the position, size, and nature of the image formed. So you draw a rough diagram and you will have to cross this off. You mark your points just for your clarity. If you can manage without the diagram, it's okay, but a diagram will let you, even at the tension of your question, of your exam, you will not, you will have still a clear clarity when you draw it on your rough area. But you will have to cross this off because you have to draw a ray diagram in a perfect, in the main area of your answer sheet. So it's given the height, right? So height is always plus. Height of the object is going to be plus 5 centimeter. Why? Height of the object is positive. That is your reason. Object distance u is equal to minus 25. Object distance is always negative. So that is your reason. Focal length f is equal to plus 10 centimeter. Why? The focal length of a convex lens is always positive. So you have to write your reason at least in a bracket, or you can say comma, since height of the object is positive, or since the focal length of convex lens is positive, like that. Then from the lens formula, 1 by f is equal to 1 by v minus 1 by u. So you formulate, you have to find the v, right? So 1 by v is equal to 1 by u plus 1 by f. You will put your values and you get your v as 1 by v as 3 by 50. So your v will be 50 by 3. Solve that value and get your answer as plus 16.7 centimeter. But if you have you have to find the magnification and height, etc. It is always easier for your calculation to have it as a fraction. So you solve it and write there, but for your calculation, you always take the value of v as 50 by 3. Okay. It is for easier calculations. Finding the size of the image, m is equal to, because you have to, now you know only the image distance, and it is plus. Why is plus? It is formed from the optic center to the right hand side of the, from F to, from O to here, it is going to be, it is formed on the, towards the right hand side. That is why V is going to be plus. So, and now you have to find your, you have the equation for magnification. So, which is equal to height of the image by height of the object, which is equal to V by U, or image distance by object distance. So you have all the V, H and U in your system. So you have to find only H prime. So you put your values and you get your H prime as minus 10 by 3, which is actually minus 3.35. The negative sign shows that the image is a real and inverted image. So the height of the object is negative, means what? It is formed as a inverted image. So the negative sign shows it's a real, and all the inverted image will be having a negative sign, and it is going to be real. So you have your negative sign because it's, and negative sign shows it's a real and inverted image. Okay, and now you have to find the nature of the image. Nature means what? You have to find whether it's a diminished image or it's a or it is a stronger image. So what you need to do, it's a you have to find your m. So m is h prime by h. So what is your h prime now? Minus 3.35 by h is your 5, which is minus 0.67. So the modulus of minus 0.67 will be 0.67, which is less than 1. So since that is less than 1, the image formed is a diminished image. So now you have to conclude, thus the image is formed. You will not say the image is formed plus 16.7. You have to say the image is formed at 16.7 centimeter from the pole on the other side of the lens. You cannot write your positive sign on your concluding statement. You have to say the image is formed. You have to define your signs. In your concluding statement, you have to say the image is formed at 16.7 centimeter from the pole on the other side of the lens. It is a, so now you have to say your H prime, right? So now, and it is and the image height is 3.35 centimeter. It's a real and inverted and diminished image. So real and inverted is, you convey the statement of your negative sign of your height as real and inverted. Your magnification is less than 1, so you conveyed the message of diminished image also here. So the image with the image height of 3.35 centimeter, which is real, inverted, and diminished. Okay, never put your signs for your values in your concluding statement. And then when you are asked to draw the ray diagram, so this is your reference diagram, right? So likewise you have to draw this, but when you draw, you have to draw only two light rays, but you will have to mark all your values, what are given in the textbook, what are given in the question, at the same time what you found out. So what you found out, you had found out your V. So V is from O to H, so you can mark it as with the arrow. I didn't do that, I'm sorry for that. I can do it right now. Okay. And also your H prime also we found out, and that also you will have to mark. Remember, according to the Cartesian sign conventions, your values should carry the positive and the negative signs accordingly. And now, the 11th question, a concave lens of focal length 15 centimeter forms an image 10 centimeter from the lens. How far is the object placed from the lens? Draw a ray diagram. So you're given the concave lens minus 15 centimeter. Why concave lens? Focal length is negative. So minus 15 centimeter. The image distance V is given, which is minus 10 centimeter. You only have to find the object. You have to find how far is the object placed, which means what? You have to find the object distance U. Only U. No, they didn't say about anything else. So answer only your question. What is your lens formula? 1 by F is equal to 1 by V minus U. So you formulate your equation 1 by U is equal to 1 by V minus 1 by F. Anyway, you know the translocation of these signs, right? 1 by U will come here, so positive. 1 by F will come here. So 1 by V, take it to the other side. So you have your minus 1 by V minus 1 by F as your formula. So 1 by U is equal to minus 1 by 10 minus of minus 1 by 15. Okay, the minus, this minus is there in your equation, and this minus belongs to the value, okay, of your focal length. So don't get confused here. So minus 1 by 10 plus 1 by 15. So it will, when you solve it, it will come as 2 by 30 minus 3 by 30, which will be minus 1 by 30. So 1 by U is minus 1 by 30, right? So U is going to be minus 30. Therefore, the object is to be placed 30 centimeter in front of the lens. I couldn't draw a concave lens properly, so I took the reference diagram and I marked my points. Please do cooperate. So this is your concave lens. All that you need to do, and you know the object and you know the image formed. All that you need to do is you have to mark your U. U is minus 30. So at least it should match a little. V should be, V is minus 10. So, and you have your Fs minus 15. So you remember, so you can mark your U at actually 2F, because F is minus 15 and you got your U as 30, right? So you can have your object at 2F and then write. And then you will be minus 30. And 16th question, find the focal length of the lens of power minus 2.0 D. What type of the lens is this? Whenever you see the minus sign, you know it is a concave lens. So given the power of the lens minus 2.0 D diopters, the negative sign indicates it's a concave lens, and you know the power is equal to 1 by focal length. So you have the focal length F is equal to 1 by P. Remember, when you solve it, your focal length will be in meters as your power is in diopters. Okay, therefore the focal length of the concave lens is minus 0.5 centimeter. Say if the question is find the focal length in centimeter, what do you have to do? You have to solve your focal length, and you know 100 centimeter is 1 meter, right? So you can convert it. So 0.5, if you want it in centimeter, into 100, it will be 50 centimeters. Okay. And now 17. A doctor has prescribed a corrective lens of power plus 1.5D. Find the focal length of the lens. Is the prescribed lens diverging or converging? By looking at the plus sign, you know it is a convex lens. So you know it is a converging lens. So now you have to express it. So power of the corrective lens P is equal to plus 1.5D. Since the sign, all your given statements, your approach of the question, your concluding statements, and your solving and your answer will carry marks. So make sure you write your given statement. So the given is what? The power of the corrective lens P is equal to plus 1.5D. So since the sign of the corrective lens is positive, it is a convex lens. So you came to the conclusion. Now power is equal to 1 by focal length. So focal length F is equal to 1 by P. Focal length F is equal to 1 by plus 1.5 D is equal to plus 0.67 meters. Remember, whenever it is in power is in D, your focal length will be in meters. The positive sign shows it's a converging lens, and thus the corrective lens is a converging lens of focal length 0.67 meters. And that's it, guys. Thank you for your attention. And in the next session, we'll be having a concise summary of the whole chapter, light, reflection, and refraction by lenses. Thank you, dears.